Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Can you explain the concept of direct preference optimization, DPO, and how it differs from reinforcement learning from human feedback, LLHF?
Certainly. Direct preference optimization, DPO, is a method used to train models, such as neural networks, by aligning them with human preferences. It is a mathematical technique that allows models to learn without explicitly calculating a reward. In contrast, reinforcement learning from human feedback, RLHF, involves two steps. First, a reward model is created to predict what a human would choose. Then, this reward model is used to optimize the main model's performance. DPO, on the other hand, skips the step of explicitly creating a reward model. Instead, it directly finds the optimal policy that aligns with the model without calculating the actual reward. This means that DPO optimizes against an implicit reward without requiring a reinforcement learning loop. To summarize, DPO is a method that aligns models with human preferences without explicitly calculating a reward, while RLHF involves creating a reward model and using it to optimize the main model's performance. DPO is a more efficient approach as it avoids the need for explicit reward calculation.
That's fascinating. So, how does DPO use algebra to define the reward and train the language models directly? Could you explain the mathematical principles behind it?
DPO, or differentiable policy optimization, is a method that uses mathematical principles and algebra to define and train the reward system for language models directly. It eliminates the need for a separate reward model. The key principle behind DPO is the use of the Bradley-Terry preference model, which is a probability framework that predicts the best option among a comparison of two possible options. This framework helps in defining the reward in DPO. In DPO, the training process involves training a language model, LLM, and defining a preference dataset. This dataset consists of comparisons between different responses. Based on these preferences, the LLM is trained to find the optimal policy that maximizes the reward. Now here's where the algebra comes in. DPO uses clever algebraic techniques to implicitly define the reward as part of the optimal policy. Instead of explicitly calculating the reward is incorporated into the policy computation. This means that the optimal policy itself implicitly maximizes the reward. In other words, the language model becomes its own reward model. This clever use of algebra allows DPO to train the language models directly without the need for a separate reward model. It simplifies the training process and makes it more efficient. To summarize, DPO uses algebra to define the reward and train language models directly. It eliminates the need for a separate reward model by incorporating the reward into the optimal policy computation. This makes the training process more streamlined and effective.
That's a really innovative approach. In terms of efficiency and cost-effectiveness, how does DPO compare to RLHF? Can you explain how DPO provides a more efficient and cost-effective way to optimize language models?
DPO and RLHF differ in terms of efficiency and cost-effectiveness. RLHF is a more expensive and resource-intensive approach compared to DPO. RLHF requires building a curated dataset, training a separate reward model, and running an iterative reinforcement learning cycle, which involves substantial costs in terms of time, money, and expertise. On the other hand, DPO offers a more efficient and cost-effective way to optimize language models. DPO does not require a separate reward model like RLHF does. Instead, the language model itself serves as its own reward model. This means that the language model is trained to maximize its own reward, which is implicitly defined as part of the optimal policy. By eliminating the need for a separate reward model and the associated costs of building and training it, DPO significantly reduces the computational and financial requirements. This makes DPO a more accessible and affordable option for researchers and developers who do not have the extensive resources required for LLHF. DPO provides a practical and cost-effective approach for optimizing language models while still achieving high performance.
That's impressive. In terms of its impact and significance, how do you think DPO can revolutionize the creation of large language models like ChatGPT? Can you discuss the potential implications and benefits of DPO for the field of natural language processing?
DPO has significant implications and benefits for the field of natural language processing, NLP. One of the key benefits is that it allows for the alignment of language models, such as ChatGPT, with human preferences without the need for a reinforcement learning loop. This means that the trained model can be optimized against an implicit reward without explicitly materializing that reward. This has the potential to revolutionize the creation of large language models like ChatGPT in several ways. Firstly, it simplifies the training process by removing the need for a separate reward model. This simplification can lead to more efficient and streamlined training procedures. Secondly, DPO enables the training of language models directly based on human preferences. By implicitly defining the reward as part of the optimal policy, DPO aligns the model with what humans consider to be desirable outcomes. This can result in language models that are more accurate, relevant, and aligned with human preferences. In terms of impact and significance, DPO can lead to the development of more useful and reliable language models. These models can be applied in various NLP tasks, such as text generation, summarization, translation, and dialogue systems. By optimizing the models based on human preferences, DPO can improve the quality and usefulness of the generated output, making it more suitable for real-world application. Furthermore, DPO can address concerns related to biases and ethical considerations in language models. By aligning the models with human preferences, it becomes possible to mitigate biases and ensure that the generated content is fair, unbiased, and respectful of diverse perspectives. Overall, DPO has the potential to revolutionize the creation of large language models by simplifying the training process, aligning the models with human preferences, improving the quality of generated content, and addressing ethical concerns. Its impact on the field of NLP can be significant, leading to more reliable, useful, and fair language models.
Thank you for explaining the potential impact and benefits of DPO in the field of natural language processing. One last question. What are the current limitations or challenges associated with implementing DPO in practice? Are there any areas that require further research and development?